Hello, this is another video from the Engineering Dude, and here we are going to be solving this problem using the component method. A good rule of thumb is to always use the component method when there are 3 or more forces at play. If there are 2 forces at play, then using the resultant method is okay. The reason why I stress this is that your statics teacher will probably expect you to know both of them, and might put them on an exam or test saying that you can only use one or the other. What the component method is that if we look at the x and y component of each of these forces, so if we call this force 3, the y component and x component of force 3, and force 2 and force 1, and we look at the y component of force 2, the x component of force 2, y component of force 1, x component of force 1, and we add them all together, so the sum of forces in the x direction equals f of 1x plus f of 2x plus f of 3x. This will equal the total force applied at the origin right here. And so if we look at the total sum of forces in the y direction, f of 1y plus f of 2y plus f of 3y, this will be the total sum of forces in the y direction on the origin. And so with any engineering problem, you always want to start with a free body diagram. And we'll draw our origin line right here. And we'll draw our force 1, which is 35 degrees, given from the problem statement right here. And this is at magnitude 100 newtons. We'll draw our force 2, which is an extra 30 degrees, and this is magnitude 150 newtons. Then we'll draw our force 3, and this is again 35 degrees, and this is magnitude 200 newtons. And we'll analyze force 1 a little bit more closely. So we'll redraw our origin line. We'll draw force 1, that's 100 newtons. And this is angle 35. And remember, what we're trying to find is the components, because we're using the components method. So we're trying to find this right here, and we're trying to find this right here, the length of both these lines. And if we remember, so katoa from trig, what we can do is we can say, hey, the f of 1x equals cosine of 35 degrees times the magnitude, so 100 newtons, and f of 1y, and this is where you have to remember that these follow the Cartesian coordinates. So if we look at our Cartesian coordinates again, the x in this direction is positive, the y in this direction is positive, the y downwards is negative, and the x to the left is negative. So if we draw this force right here, went in this direction, so the x is positive and the y is negative. So we do negative sine 35 degrees times 100 newtons. And this is, we'll leave this for here for right now, and we'll get back to it later. All we gotta do is plug in the numbers and solve them. So if we look at force 2 right here, force 2 is 65 degrees. We just added 30 and 35 together right here. And the magnitude is 150 newtons. And so we can do the same thing we did down there. So force of 1x equals cosine 65 times 150 newtons. And force of 2y, this is supposed to be 2, my bad, equals sine 65 degrees times 150 newtons. And we'll just leave that for like that for right now. We'll look at force 3. So force 3, 35 degrees, and it's 200 newtons. And so force of 3x equals cosine 35 degrees times 200 newtons. And this force is pointing in this direction, so our x is actually negative. So we gotta put a little negative sign up in front. And force of 3y equals negative sine 35 degrees times 200 newtons. And so now, since we have f of f1x, f2x, f3x, and the same thing with y's, we can just plug and chug into this equation right here and find out what the total force in the f of x and f of y direction applied on the origin is. So I've written this down already to where f of 1x equals 81.92. F of 2x equals 63.39. F of 3x equals negative 163.83. And f of 1y equals negative 57.36. F of 2y equals negative 135.95. F of 3y equals negative 114.72 negative. And so the total force, the total sum in the x direction is equal to negative 18.52, and the total sum in the y direction is equal to negative 308.03. And if we look back, these are the components, but what we need to find is the resultant. And remember, the resultant has to have a direction, and it has to have a total magnitude. So to find the magnitude, all we do is square root f of x squared plus f of y squared, and these are the sums. So we just put this in there and put this in there, and what this comes out to be is 308.59, and that's a magnitude. And now we gotta find the angle. So if we kind of figure out what we did right here, if we redraw it and we plot these points, so in the x direction we have negative 18, and in the y direction we have negative 308. So we have a force that kind of looks like that right now. And we want to try to find this angle right here. And to find this angle, we can use tangent, so TOA. So the opposite over adjacent. So the opposite is, so if we do tangent theta equals opposite, which is 308.03, over adjacent, which adjacent is negative 18.52 negative. And if you move tangent to the other side and you solve for theta, this comes out to be 86.56, and this is from the negative x origin. So your final answer would look like this: 308.59 newtons at angle 86.56 from negative x origin, like that. And now, I guess depending on the type of problem you're doing or whatever, your teacher might want something else. If you want to find it from the positive x origin, you just subtract it from 108 or 180, and that would give you negative 93.44. And so, I mean, usually I would say this is fine, as long as you draw this symbol right here. But if you don't draw that symbol, then you need to put this symbol right here. And yep, then we're done with the problem. Okay, bye.